All right, welcome back. We're here on 5.3. We're going to be talking about solving quadratic equations by graphing and factoring, a couple different ways of doing it. So what we're trying to find is the zero. What makes it zero? And really what we're looking at from a graphical sense is where does it cross the x-axis? The zero is also thought of as roots, and also the x-intercepts are all synonymous, really exchanged. So what we're going to realize is that the axis of symmetry cuts right in between those, obviously, as we go. All right, so let's find those by using a graph on a calculator. All right, that's the first order of business of what we're going to do. So the first thing we're going to do, let's look at Desmos just to see how ridiculously easy this is. I think I have that sketched up. That's typed in correctly. So to find the zeros, all you do is you type it in. Well, there's your graph. Well, at 2 and at 4, it's just that easy. Yeah, you just touch it and you're good to go. All right, so let's go back. Let's see if we can figure out. I want to see if we can do it with a calculator here. I think I've got it. We can get this come up here. Calculator, please. Let's slide that over. There we go. Let's get our calculator. Now, with the calculator, what you want to do is you want to hit the y equals button here. That'll get us in. We type in the x squared minus 6x plus 8. All right, and then what we're going to do is we're going to graph it. Okay, get the same graph as we do on Desmos. Not quite as easy. You don't get just touch it. You can kind of see that it's going to be at 2 and 4 as you do that. But one thing you have to do to find out what that is hit second. The second button there. Whoops, that's not going. Let's try it again. Second. I don't think I'm hitting that right. Use my finger. It's not working. Second, calc. And we're going to try this number 2. We're going to find the 0. Let's go to number 2. And left bound, all you have to do is put that on the left side of the 0 that you're trying to find. So again, we're going to try to find this 0 right here. So it's blinking. It's on the left side. So once it is, you hit enter, and then right bound, we have to put it on the right side of that 0. All right, now here's something as you hit it. Now what you see is the calculator is saying, all right, look for that 0 in between those two lines. All right, because there are a couple of them, it doesn't know which one you want. It says guess, you never really have to guess, just hit enter. And it tells you that first one is 2, the 0 is 2. Now we go through that same process again. We'd hit second, calc, and then we're going to find the 0. And this time left bound, we're going to try to find this 0 right here. So that's on the left side of it. That's left bound. And then right bound, we're going to scroll over. Anywhere on the right side of it is fine. Hit enter. You don't need to guess. It's right there. There it is. It's 4. So as you can see, Desmos kind of is quite a bit easier. Calculators are good, though, in some senses to use that. That's just kind of how you have to do it. That left bound, right bound thing is kind of weird and awkward. But so are a lot of us. But so it works, and we get the stuff done, and it's okay. All right, so we can always find those. Again, the zeros, we're looking to see where they cross. Now, we can also do a lot of this by factoring. All right, now factor, you guys remember to do this. Now, remember factoring this trinomial, what you're going to see is that we're going to look at factoring into two binomials. We know to get x squared, we have to go x and x in the first spot. So now I have to think of two numbers that multiply together to be negative 12, but add together to be negative 4. That's where some ingenuity comes into play. Well, what happens is we get x minus 6, a minus 6 and a positive 2. These two numbers, because when you FOIL this out, you get the x squared, you get the negative 6x and the positive 2x. That does add to negative 4x, and negative 6 times 2 is negative 12. So it does work. So we want to know what makes that 0. Well, 6 minus 6, it's the opposite there. 6 would make that 0, and then negative 1 would make that 0, because, I'm sorry, negative 2. I can't even read my own writing. Negative 2 is what that should be as we go in there. Okay, so that's solving up by factoring. That you'd get the same zeros if you were to graph it and do it that way as well. All right, now in this case, if you only have two terms, what you want to do is you want to factor out what's in common. So we can take a 3 out of here and also an x. It's kind of like undistributing if you want to think of it that way. Well, if I remove a 3 and an x, the only thing I have left is an x. And if I take out a 3x, well, what multiplies there is a 6. So the question might be, what makes that 0? Well, 3x equals 0. Well, if I divide by 3, that means x has to either equal 0, or in this case, we know that x would have to be negative 6. Those would be the two zeros that we get. Again, you get the same thing by graphing, but working on those factoring skills. That's a little review from Algebra 1. All right, let's try another one here. Factor, we have a trinomial, so we're going to go x and x. And so we think, what two numbers multiply to negative 6 but add to negative 5? Well, I think we'd have to go negative 6 and positive 1. That would multiply to -6 and add to -5. So our zeros would be 6 and -1. Okay, now it takes practice to get to see those. Sometimes you just got to put numbers in, see if it works. If it doesn't, try something else, and you'll get it. All right. So let's kind of talk about some motion here as we have some general formulas. As we do projectile motion, kicking a ball, throwing a ball, hitting a ball, whatever it is, we have a constant due to the Earth's gravity, and that's negative. That's the -16 t squared. That's the part that we have. That's Earth's gravity. It's different if you're on the moon or something else like that. The coefficient of the t value or the x value there is going to be the initial velocity. So how hard do you hit it? Obviously, that has a lot of impact on its path and how far it travels and how high it goes. And then initial height, of course, is what you start at. So if you're hitting it off the ground, that's going to be 0. If you're like throwing a baseball, it could be 3 feet or whatever you want. It could be a lot of different things as we go. So we want to be able to model that as we go. So a golf ball is hit from ground level with an initial velocity of 80 feet per second. So it's a ground level, so we know that initial height is going to be 0. Let's go back to our previous. So we're going to go -16t squared plus 80t. That's what we're going to look at here. Okay, so -16t squared plus 80t. Now technically we'd have a +0. We don't need to really include that, but that would be the modeling equation that we would use in this situation. Okay, so we're going to go on. We're going to write that down. Okay, we've got it. And so when will hit the ground? Well, what I would do, you can factor if you want to. Factor out a -16t, and you with t minus 5. Well, your zeros then are going to either be 0 or they're going to be 5. And again, that's something you could do with factoring. Personally, what I would do is I just graph it, and then you can see clearly on the graph that it equals 0 and 5 is where it hits. So a lot of times we look at things of, okay, if I do this, if I hit this ball at this velocity and this height, when does it hit the ground? We also talk about what the maximum is, and we know how to find that as well. And I think graphing can provide a great way of doing that as well. All right, now there's some special types of products and factors. One's a difference of two squares. So if you have something like x squared minus 25, which is a perfect square, you can factor that into x plus 5 and x minus 5. We have perfect square trinomials. That's where you get the same factor in each one. Okay, so we'll kind of show you how that works here. So solving this, find the roots of the equation. In this case, what I would do is get the x squared by itself. So we'd have x squared is equal to 25 divided by 4. And I'm going to leave it like that. So to find x, what we'd have to do is take the square root, plus and minus 25 over 4. Well, we're going to have two. We're going to have a positive and negative version. If you take the square root of both those, that's just going to be 5 halves or 2.5. But there's two of them. There's one at positive 5 halves and one at negative 5 halves. There's two roots that we get there, two zeros that we have. All right, how about this one? Now, again, when you have problems like this, you want to get everything over to one side, zero it out. So we're going to have x squared minus 4x. Bring that over, we're going to have plus 4 equals 0. And this is one of those special factors when you think about it. We're going to what two numbers multiply to 4 but add to -4? Well, -2 and -2. So there's only one 0 there, and that's at 2. So what's happening there is you're having the parabola, and it's just the vertex that's hitting that x-axis. There's only one root or one 0 that happens there, and that can happen. We'll talk later on about the fact that, yeah, it can also be where it doesn't hit it at all. We'll talk about what happens in that case later on. All right. Now, if you know the zeros of a function, you can always work backwards. All right, so if we know the zeros are 4 and -7, we can always go backwards. Well, the factors must have been x minus 4 and x plus 7. Well, now distribute that out. We get x squared plus 7x minus 4x minus 28. So we'd end up with x squared plus 3x minus 28. There's our original equation that we have. Okay, so just working backwards on that. We did stuff factoring where we start here and go to the end, but now we're working it the other way. All right, how about if we have 5 and -5? Okay, well, what are the factors then? Factors would be x minus 5, x plus 5. Well, we'd have x squared. Now look what happens. We'd have a -5x and a positive 5x. That cancel each other out. And then minus 25. So there we go. We have that difference of two squares, that special factor that we have there. So those are kind of nice when you do those.